Welcome back. It is a Monday. Happy Monday to everyone who is out there. So I had a brainwave. While I was sitting here and just getting started. Because I've tried to do a thing where I do a little bit of, I sit down and I warm up and I recheck out where I was before so that, we're not left confused and just watching me try and remember what the heck I was doing on Friday. But I think I've got it. Let's bust into it real quick. So, I wrote this out just to sanity check myself. So, I looked at the Kupol, right? Because I was thinking, let's start by looking at this and see if anything really obvious stands out to me in terms of things just not being mapped right in the SRAM memory space. And so we're using the way things were going Friday. Things worked when the only thing I had mapped into the memory space at all, if my camera decides to stop going insane. Okay, it's fine now, whatever. When the only thing mapped into the memory space, and I wasn't using any of the address lines, and I was only using the SRAM select, was the toggle LED thingy, everything was fine. And then as soon as I introduced A11, it wasn't working properly. And I'm using A11 because that's my highest bit that is still within the SRAM address space. And you know what? If you just count a little bit, so theoretically the way I have it split up is the LED for the little toggle register for resetting the floppy drive controller, which I have a whole extra idea for that now, is at addresses 6,000 to should be at address 6,000. I don't want to give away too much about what I just realized here that was stupid. And then when A11 is low, it addresses that, and when A11 is high, it addresses the floppy controller. Well, you know what? So this is correct for handling for addressing the little toggle register thing. I used 6107 in this code for accessing the floppy register. Yeah, A11 is not the first bit of the third nibble here. It is bit 0, bit 1, bit 2, bit 3, bit 4, 5, 6, 7, 8, 9, 10, 11. It would be the 8th bit. So you know what's totally happening, and I feel pretty good about this. This is in the toggle register address space, and so is that because it's not above 6,800. So I'm pretty sure that's all I need to do to fix this for the moment and get us accessing the floppy drive again. So that's cool. And the reason that the LED doesn't seem to toggle at all, and so that doesn't seem to work either, is because it's getting toggled twice every time this loop happens. So it gets toggled on and off, and then it's back where it was before. So, hey Wereworm, hey Dave, this is my thought. And also I had a whole I sent a whole bunch of YouTube messages at Wereworm, I think Friday night after I stopped streaming, because I was trying to find other obvious pins that I hadn't looked for, because I hadn't been looking, that were available to me on the cartridge port that could be used as reset signals. Wereworm has had some good suggestions. Of course, the original good suggestion is just use an RC-based reset circuit, which is totally yes. But there is also, I might want to test it. I might just not get around to it today, because seriously, all I want to do today is just knock out a short one and see if this just fixed my reading from the chip, and then see if I can write to the drive select register and turn the floppy motor on. That's all I want to do today. And actually, do we already have code for resetting? Did I comment out the code for resetting the floppy? Well, whatever. The thing is, if this register works, it's attached to the floppy reset, so if I rewrite the code that I kind of had last time for toggling that once at power on, then we should be fine. Anyway, that's the general idea for today. So I just built this. Let me build it again, because why not? And let's burn an EEPROM and see if all our problems go away. If it's as easy as that. Okie dokie. Cool. We're still on EEPROM mode. So all I have to do is put the 1 there and hit the program here and hit the program and go, hello, Daniel Rodriguez. Cheers to you as well. All right, we are written. Let us not waste time. And to the game capture. Okay. Oh, you can't see that. There's a reason I had this whole thing. There we go. With the video game capture in there. Anyway. So, yay, that's working again, which pretty much confirms the entire theory because, you know, that toggling and whatnot. And then, let's see. So, what's being printed in the register up there, right now this is being grounded, so I can never remember which frickin' pin is the one that, but we'll find out when we see if this changes anything. Can't remember if there's a pole anywhere in here. Yay, look, I don't ground it. There we go, it's working again. Perfect. So we have things mapped into SRAM address space, and they are working a treat. Good enough for me. All right, so let's say we just fucking go for it and plug in the floppy and turn on the power and turn on the drive select motor. So I guess firstly, I'll just do exactly what I said and get rid of this. Well, wait. Haha! No, I had stashed all of my code over here. The fun thing being, it just toggles. It doesn't actually read from the data bus because I couldn't figure out how the frick to make that work. And we're just going to ignore that now because according to the datasheet, it always starts up. All of the D flip-flops reset to on. So I just have to turn it off and then on again. And that should be the entire thing. So, because this is overly complicated, because it is storing a 0 to 6,000 and then storing, yeah. And then we had this wait loop and stuff, which is probably, So I guess this would still probably work. Let's see, it'll start out on, so it's kind of going to be the opposite of this, because I started out by turning it off. So really, let's see. I guess I just add one more step. So I can't remember if it cares about whether it's being read to or written from. It really shouldn't. I mean, like, it doesn't matter. Let's see. No, it doesn't care. It doesn't care. It only cares that the SRAM memory area is being accessed and A11 is low, and that's it. So, I guess store? Why not? So, if we store 6,000, this should turn off reset signal, and then turn reset signal back on, and then we'll do this reset loop for fun, make sure it has a little bit of time, and then finally, yeah. So it's just the same thing, but I got to remove some instructions. That's fun. And that should be that, I think. So we just need to transplant this. Whoops, nope, I don't want to save that. Actually, I want to transplant it back into my other code. Right after... right after initialization. Turn reset signal back off. Now, I really doubt that matters for turning on the drive motors, because I imagine that doesn't really have much to do with the internal logic of the chip at all. But whatever. It's there now. So now I'm going to get rid of... Oh, yeah, I'm going to get rid of this and this, just like I had done last time before everything stopped working again, because we don't need to write to that toggle register now that we're using it for reset. And yeah, I guess, should we just, well, let's look at the data sheet. All right, first I'm going to check chat, because I see where Worm popped in. I have ordered an N82077 for my tinkering. I was afraid of floppy disk stuff before, but with the integrated PLL, I have hope now. Yeah, it's my understanding that this chip takes care of a lot of shit for you. Again, I've, like, I think it was you, I mean, everybody seems in this scene is probably more or less familiar with the OS Dev forums, but the OS Dev wiki has relatively decent documentation on the floppy disk controller, and it's that floppy disk controller, and, like, once you have it wired up properly, that's pretty much it as far as I understand here. Of course, that's what I said at the beginning, and now we're 9 episodes deep into getting the floppy working, so yeah. Anyway, all right. So, one thing that we're definitely gonna have to do, I think. Oh no, I did actually connect up the read and write signals to both the floppy read and write pins. So I would assume that if it's working for read, it's probably working for write, because they're basically the same thing, except I have one of them inverted for writing. So let's look at the documentation and see where that drive status register is. And poke it, I guess. Which I think I should be able to see on the output of the... Oh, well, I just remembered. I was going to say I could see that on the output of the floppy disk connector, but my multimeter, I never replaced the battery. Well, we should probably be able to use an LED to check that. Probably. Bit savers, here we go. So, which register is the one that you turn the motors on with? I guess we need to go to the All About Registers section. Oh, wait. I can look at drive signals here just because I'm curious. Is just drive select the one that turns on the motor? Oh, maybe it's ME, motor enable? Maybe? We'll find out. Anyway. Status registers, blue. Where's the one that has... I don't really care about the status, because we need to put this thing through a whole reset before we start doing stuff besides turning on the motor. But... yeah, here we go. It is. It's digital output register. Digital output register contains the drive select and motor enable bits, a reset bit, and a DMA gate bit. The motor enable bits directly control their respective motor enable pins, ME0 through 3. A 1 means the pin is active. Oh, and I didn't check, is this read only? Because that would also be useful if I can write to it. Haha, it is read write. So at address and at register 2, I can read it or write it. So that would be a great place to start, is literally just like turn on one of the motor signals and then read it to make sure that it is in fact on. Yeah, that's the way to go. So maybe what I'll do, just for starting to play around with things, is set bit 7 and then switch the register that I am, because bit 7 is motor enable 3, which is not the one that I will probably be using here. I will probably be using motor enable 0, but you know, I'll just set bit 7 and then see if bit 7 is set when I read it, and then we will move forward from there. Baby steps. And that was register 2, right? It'd be really cool if they had, like, the address of the register right next to the description, but no, I have to scroll all the frickin' way back. Yes, register 2. So this should be 6802. And this will also tell us, because it's the first time we've tried to access a PS2 mode register since we have switched the chip physically into PS2 mode. So hopefully that works too, because we haven't tested that yet. But okay, now that we've got that, yeah, all I really need to do is load a 80. Let's see. What are all the bits? Because, of course, the first 4 are... Let's see. Yeah, the first 4 are motor enables, then DMA gate and reset, or not resetting. I'll have to check to see what that actually does, because also you use that to reset the thing, and that is probably how I will get it to... I think you need to do a power, like, reset on the actual reset pin, and then do a software reset on here before the, like, drive internal logic is, or the controller's internal logic is ready. But so this is all 0 during hardware reset, so I think it's fine for me to just write zeros to everything. Anyway, right now all I care about is, can I see that bit getting written? So store that to 6802, and that should be that, and we should read it, and we should see an 80 whenever we press the keys, if I am understanding things correctly. Right, here comes the traditional programming of the doodad. No, I want to load the new code. Go! Yeah, you did it. Amazing. We were all rooting for you. Oh, the power was on there. Whoa, whoops. Whoopsie. All right, what will we see? We will see 80 hex, also known as 1 blah, 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 binary. Heck yeah, brother. And if we look at these pins, let's see on the floppy controller, what pin is motor enable 3? Give me a decent pinout. Do any of these have decent pinouts? Motor enable is on pin. I like how they just kind of vaguely point in between these pins. It's very good. Very good. Motor on 0, motor on 1. Really? Did the other two motor on signals not even go to the connector? I mean, that wouldn't be surprising, because, you know, on a PC it only supports two floppies on the chain. So, what was I going to look at? I was going to look at something. Oh, I was going to look back at the data sheet, because later on they have the application note around which I built this circuit in the first place. And that will show me what wires I ran where, because I just followed the instructions there. And I have clearly shot right past it, because I don't know where it is. Sorry, bear with. Oh, maybe you would like to see my screen. Is this it? I think this was it. Yes. Yep. Okay, so motor enable A, motor enable B, and they didn't connect the other ones. Yep. Let's see. let me trace these back. Motor enable A was here. And, oh, yeah, so motor enable 0. Where are the rest of the motor? Motor enable 1 went to motor enable B. And then the rest of them just straight up aren't connected. So yes, I will not see those on my connector. That makes sense. Okay, so then in that case, let us turn on motor 0 and go for it. Oh. It just goes to show that my connections are totally redundant, but one of my wires came loose on my connector. It was about time, but this one, yet again, broken. Well, we'll get that fixed up, but while my iron is heating up, let's change this code around, and that would be just 1 0, right, for motor enable 0. And that really should be that. And then I guess we can plug a floppy drive in. There's nothing stopping us at this point, except for my own fear. Wareroom said, I have read that some signals are inverted for 3.5-inch drives. I have read that as well. We'll have to re-review because I don't know where or what or how that works. Okay. Yeah, that was the whole thing, right? Build, and load. And okay, power off. Program. And I mean, it seemed to be working without that pin attached. I don't know what that pin is. It's supposedly pin 1. What does pin 1 do on the SRAM? Does it even flippin' matter? You'd think I would know after dealing with it for this long, but no. Give me a pinout. Give me a pinout. Pin 1 is a no connect. So, fuck it. Just fuck it. That's fine. Whatever. Back to the bench. Alright, so firstly we should see what's in the... Yeah. Oh man, it's nice that it's so nice that it just works. It just works. That's so cool. It's not flaky or anything, it just... I write the value to it, and then it has that value. And that's it. So, I'm going to turn this off. Wait, no. 1 second. Let us be even more pedantic here. Where was the motor on A? Motor on A is pin 10, 2, 4, 6, 8, 10. So pin 1 was over here. So 2, 4, 6, 8, 10. That should be motor enable. That should be the one that's on. And what am I looking for? An LED. Surely I have one sitting around, and yes I do. Would you look at that? I know, this is really just kind of wasting time. Like, obviously it's doing what I expect, but I'm just doing this because I want to. And seeing as that's like the whole purpose of the entirety of this project, I don't see why you wouldn't just let me have this. Yeah, David Cooter says, need to get a simple monitor ROM in there so you can do some peeks pokes from the keyboard without reburning the ROM all the time. Yeah, you're right. I have nothing to say to that except for that's pretty clear. but I'm taking my sweet time, okay? Interesting. I wonder if motor enable is an inverted signal because it's off. Let's see, where's motor enable B? So it's motor enable A, then drive. Yeah, they are inverted. Actually, I'm looking right at them because drive select B is off. I know that. And theoretically, drive select A would also be off, but I don't know. And then motor enable A, or motor enable B is off for sure. So, yeah. So that tracks. That should be off. All right. It is interesting that, because it's supposed to be, so it's supposed to be density select, no connect, and no connect. Index, motor enable A. Drive select B. Drive select A. So by turning motor enable A on, does that just automatically also turn drive select A on? Because that is a different signal in that register, but whatever. And then motor enable B. So I don't know what's up with that. Maybe there's just a thing I don't understand, but Worm says the code is ripe for some refactoring anyway. Yeah, to put it mildly. Anyway, okay. Next thing then, I think, is for this code, I'll print the register, but also I want to, if I'm just going to be turning the motor on and off today, then I might as well at least turn the motor on and off every loop. So I guess I'll just kind of do what I was doing before with the LED, which is just let's load a, yeah, I guess let's load a 10. We'll start by, just like I was doing before. Load A, we'll start with, I don't know. I'm just gonna load 0 into it and push it. And we'll do the same thing that I was doing before, which is just pull it, store it into the register. What was that? That was 6802. And then exclusive or that with a literal 10 to toggle that bit on and off. And then push A back on the stack. There we go. And so that should turn that motor select signal on and off every time that I hit a key now. Dave Cooter says, Waz's is 2K. I know. It would be easy and straightforward. But not tonight. Maybe a different night. But a monitor would probably be the right thing to do here. Okay, maybe we just get the floppy drive roughly working, and then we do let's write a basic monitor. Because, I mean, it would be pretty easy. The monitor I wrote for the 65816 computer took me a little while, but it's mostly because I had to deal with a bunch of the weirdness of the 65816 and being able to access its entire address space from the monitor and stuff. So we could probably knock out a pretty simple one. Right, so I built it. I load it. I turn off the NES. I burn it. I test it. firstly, I would be expecting that to toggle, so that is clearly not doing what I want it to do. That register should be changing its value. What am I doing wrong here? Am I not understanding exclusive OR on a 6502 properly? Is my stack getting corrupted? Who's to say? Boy, if only we had a monitor to work this out. I mean, that should work, right? Exclusive OR and then just push it back on the stack. Unless my stack's just getting totally screwed up for another reason. I mean, we use it here for the bit shift printing stuff. But, like, that's it, really. Well, just to rule out things screwing up my stack. I mean, if the stack is screwed up, it would be really screwed up. So, anyway, let's just add a 0-page thingy. Motor status. And it looks like we'll put that at 0C. Okay. So, never mind this business. Well, do load A, but then store it at whatever I just called that, motor status. And don't do that. Just do load A motor status. And this feels kind of silly to me, honestly. There's no way that is the issue. But I guess we'll find out. Load it up, program it in. If I had a monitor, this would be way easier. Power off. Program on. See if that made a lick of difference. I strongly doubt it. No, it did. Okay, I have no idea why it didn't like being on the stack or what the stack was screwing up, but I should be concerned about the fact that my stack is not, you know, keeping values properly. So that was on 10. And I mean, I know this will work, but I'm just going slow. Deal with me. 2, 4, 6, 8, 10. Okay, more toggling things on and off. There we go. That's motor on, motor off, motor on, motor off, motor on, motor off, motor on, motor off. Cool. Let's go insane and attach a floppy to it. I'm going for it. I mean, why not? It's not like turning the floppy motor on is like a really intense, difficult thing that will blow up the floppy if not done right. It's like the basic thing that a floppy does. It's like the minimum of floppy functionality. Now I just have to figure out where my power cable is. Oh, I'll just steal it from my desoldering pump. Genius. And I had stolen the floppy cable from the one computer and put it somewhere. And do we have any idea where that is? Because I don't see it right away. Good job. You have already lost it. Oh, there it is. Okay. Here's the thing. This cable is a single floppy cable, and it already has a twisty in it, and I can't remember what the twisty twists, but we might be turning the motor on the wrong drive. We'll find out. But this is exciting. I have had this board kicking around for so long, and I have never once actually plugged a floppy into it. So, this is super fun. And a little scary, if I'm going to be honest. Okay. Floppy power on. Okay. NES power on. Yeah, I don't think it's... I think it's probably drive B. Because I don't hear nothing coming out of this drive. LED's on though, so that's fun. Okay, let's adjust the code again. Make it do drive B. And that is to make sure I am clear. Worm says, the Royal Society for putting things on top of other things would be proud of you. They would be the only one. The only ones. Right, I was double checking just to be super, super careful. Which bit was motor enable for drive 1? Which I'm sure is just the 2's bit. But you know what? You know what? Let's live a little bit. Make it the 2's bit. Just go for it. I already know it is. I just need to get over being so dang nervous about things. The one thing about doing this at night is that it's just so dang quiet. It's spooky up in here. Okay. Yep, I'm clearly doing something wrong. I wonder if I have the cable in backwards. That would be insane, right? I mean, they're keyed. They can only work one way. It just seems weird. And also, like, it shouldn't matter. It's twisted. But that's it. Like, it shouldn't matter which end the twist is on. Like, what happens for shits and giggles if I just manually ground the motor on the floppy, just to make sure? Derek Koenigsberg says, as far as I know, the pin 1 stripe is supposed to be on the side with the power connector. Yeah, well. Oh, shit. Yep, nope, yep, wait. Yes. Yes, was this wrong? I don't know, let's try this again. I think it may have been upside down. Which would be awesome. Well, unless it broke things, but I don't think so. But I think that was upside down. I think it was that simple. Because I just wasn't even paying attention to the fact that this floppy doesn't have a shroud on the connector. Because it be old. Oh, I should probably turn the power onto the floppy. Not that the order really would have mattered at that point, but whatever. Okay, that's an interesting sign. I turned it on, and the the drive light went out, which, as far as I know, is controlled by the drive select pin. So, okay, that still didn't work, but potentially now it might be back to the fact that this actually is drive 0. Let's try it again. Let's try it again real quick, like. Power off. Chip out. Over here. Pop it in. I'm excited. I think this is happening. I mean, it's such a minor part of the getting a floppy drive working, but it's going to make noises, and that's going to be cool. Okay, build, load it up. Come on, I don't have time for this. That's totally not true. We've been streaming for 40 minutes, and I said all I wanted to do was turn on the drive motor, and it looks like we're going to do that in just a second here, and so I have plenty of time. Well, I would be willing to make this just like the world's shortest episode. I don't think many people tuning in to catch up would mind that at all. Anyway, I'm programmed, right? Yes? Yes, I am programmed. Okay. Hold on to your booties. Interesting. Interesting. It causes... Oi. Oh, you can kind of see it there, maybe? It causes the drive light to come on and off. Like, it's just the drive select that's being set. But that should be the motor control. The motor should be turning on. So that's interesting. But it's doing something, so that's cool. You know, unless I blew it up. and power is on. So anyway, it's doing stuff. Maybe only if a floppy is inserted. I find that questionable, but let's find a floppy. Let's just find a floppy before we start casting aspersions. Anybody has a hookup on a good, affordable source of floppies, let me know, because I have precious few. Well, it does seek with the floppy in. Oh, and the motor is on. So, there you go. And it turned off the second I turned the power on, the whole thing reset, so... yeah! Points to you, Wear One. Ta-da! We did it. There you go. Project over. I don't know what to do now. I guess it would be resetting the floppy controller and reading shit from here, but I think I will make this the world's shortest episode, because why not? I just wanted to turn the frickin' motor on this whole time. So now we have to actually write actual floppy crap. So should we take a break and write a monitor? Monitors are easy. Monitors are fun. Okay, they're easy. Okay, they are monitors. It's easier than writing an operating system. But yeah. Monitor would probably be good to have regardless, because if I want to boot stuff off the floppy, it would be cool to have a monitor to, like... I don't know. Maybe we... because this is what I was trying to decide last time, is... do we just put basic on the ROM, and that's our fallback? Like, we have a little tiny bootloader for floppy stuff, and if there is no bootable floppy inserted, based on whatever scheme we figure out, then we fall back to basic on the ROM. That's kind of what I want to do, because that's pretty... I mean, that's basically like an IBM PC, so that's pretty straightforward. I mean, it's also like Apple II auto boot. I don't know. I'm not familiar with a lot of 8-bit machines. So my apologies. But yeah, motor's on. Oh, Dave says you got to catch up. I got my hard drive controller written and working today. Look, Dave, you're actually like a capable and brilliant hardware engineer. So I can't compare myself to you. Oh, Derek said, Return to Monkey Island came out today. Going to be an unproductive night here. I heard that from my work buddies because they said, are you going to be playing that because you're the nerd guy? And I told them, first I would have to get more than an hour into, you know, the original Monkey Island. Let's port Monkey Island. Wait, that might already be a thing. Was Monkey Island ported to any consoles? Dave says, kinder words were never said, but I am honestly an idiot who gets lucky. No. Nope, get out of here. There's no way somebody builds an Apple II and an FPGA from scratch in a couple days and isn't very good at what they do. Yeah. No, seriously, I think I'm going to call it because it just feels nice to have a short night and actually have everything work for once. And next time we can go in knowing that we are actually talking to everything correctly. And that's fun. And I'm just going to sit here for the rest of the night and turn this floppy drive on and off. For it makes me happy. Okay, that was an easy one. I needed an easy one. Thank you all. I will see you tomorrow. And until that day cometh, see ya. I love ya. Bye-bye.